And we are moving on into lesson 11 of our Python course. So, as you can tell from the stream title, we are going to be going over something called modules and packages. And so, we kind of learned before how to write the code, how to compact it into functions and stuff, and all of that's cool, but there's so many more things you can do in Python. And what I mean by that is many times other people have written these bits of code for others to use. And in order for you guys to access this code, they have to be like imported through the web, either through something like GitHub or like Stack Overflow, or even just emailed as a repository towards you. And you have to learn, okay, well, how do I import it and how do I use it? And this is where modules and packages come into play. Because what modules and packages do is it's essentially just compacting the code except to another level. And the level of this compaction is a file or a folder. So this is kind of our introduction to modules and packages. So we talked about code reuse last class, and code reuse includes the basics of kind of abstracting, compacting all of your code, and being able to use it over and over again. And we learned that the most basic form of this code reuse comes in the form of functions. And so we learned all the basics of functions. They're pretty simple. It's essentially just going ahead and writing whatever you code and calling that function as many times as you want. And we also talked about how there's different kind of layers of this code abstraction or code reuse. And we saw that kind of small, I guess, chart, and we can see that the lower level is functions. We have a second level of classes and objects, and a third level in modules and packages. And now you may be wondering, well, why did we just go ahead and skip over classes and objects? Well, we didn't exactly skip over it. We're going to be going over that next class. But to kind of give a reason why, it is because classes and objects are considered an essential in many other computer languages, including Java and C++. However, in Python, classes and objects are not essential. And as a matter of fact, many people don't even need to use classes and objects because they can directly kind of compact their code into modules and packages. And as this course is tailored more towards the Python language rather than towards programming languages in general, we decided that it would be better to kind of review over modules and packages before we go over classes and objects. And now you may be wondering, well, why is it that classes and objects are more used in other languages than it is in Python? Well, in other languages, classes and objects are a part of the program that cannot be ignored, because without it, the program cannot run. And so basically, you need a class in order to run the program. And in Python, this is not the case. As we can see, we can just write a basic program ourselves, like just printing out hello world. And we can see that that's just one line of code. There's no class, there's nothing fancy about it. And so many times, Python programmers, all they need to do is just write their code into functions, put it into a file or a series of files stored in a folder, and then ship it away. Either downloading it and making sure you like put it online for others to use, sending it to some friend so you guys can complete a project together. But essentially, what I'm trying to say is in Python, it's almost as if classes and objects is a skippable step. Now, it's still an essential part of code reuse, and it is why we're going to teach it. And there's also something special about classes and objects, which we will go into next class. And I guess that is our main reason for why we're going to be skipping over classes and objects for this class, and we're going to be going directly to modules and packages. Alright, so Python modules are essentially just Python files with the extension .py. So as you can see, there's the example over there, Python program.py, and you can pack as many Python functions as you want into a single file, and as I said, you could just put it online, email it to your friends, and everyone can just kind of download it and use those functions, or programs rather. And so these files, we can see that there are some similarities with functions, and some of those are that we can kind of package all the code into a kind of compressed environment that we can easily reuse, or we can like easily send off. And so that kind of shows us, well, code reuse is in fact a very broad concept, and it can apply to many different layers. So in Python modules, this is very, very essential, as it allows multiple programmers to communicate with each other without actually having to be there in order to say, like, see the code and copy it. So I'll let you look at this slide for a second. Alright, so here is an example of a module. And so we can see we have two different functions here. And you're like, well, yeah, we just wrote two different functions. What else is it? Well, if you check, the file name is called checkPrimeModule.py. And you're like, oh, okay, well, it has the module ending with the .py at the end of it. But then you will also notice that .py is actually found in all of the programs that you write. And this is quite neat, because essentially what a module is it is just a file. There's nothing else special about it, other than usually when you write a module, you have the users in your mind. So you make the file easy for users to kind of edit, to kind of look at. And typically in modules, there's a bunch of functions as well. And these functions are what ultimately allow you to use it in a helpful manner, either importing it into your other programs, checking out how a certain function may work, doing some sort of calculation that you need. There's many different uses for functions, essentially. And so you can always just, like, say, email a singular function to your friend and just kind of copy and paste the text, or kind of just copy and paste it into like a Stack Overflow post. But it's always much easier if all the person on the other end has to do is just simply click one button, downloading it, and they're able to suddenly open it, use it, no hassle at all. There's no reformatting, there's no kind of repositioning anything. It's all kind of there for you. So that is kind of the advantage of using a module. So here's an example of another module. So we can see that in this program over here, this was like a module that we wrote ourselves. And say we want to use this method in another program. Well, how will we do that? So we come over here and we write this line: from checkPrimeModule import star. So what does this line mean? Well, so we have two kind of English words here, and we have two kind of special words slash characters. So we have from. So what from means is this is your base file, the file that you're importing from, right? And so we also have the file name, checkPrimeModule. So that is going to be your second word. Your third one is going to be import. What import means is that everything inside that file, you want to bring it into this file. And what the star means is all. So you can see that two of them, the non-orange ones, are kind of exchangeable, I guess. You can change it with other file names, you can not import everything, just certain parts of it, and that is kind of how you're going to be able to import your modules. And all of the functions that were defined in check prime module can now be called in this program called main import module. And we can see we have prime checker num, right? So there's no sign of prime checker num in this program, but if we see over here, we have prime checker as the first function, and so that means that we can now call it. And we see find all factors at the bottom as well, and we can see find all factors is in this program as well. So I'll let you guys look at these two slides a little. So now that you guys have had a good look at this, so this is kind of the very basics of a module. We can see, alright, a basic file import, and from that file we can just call it in our main program once we write that line of code. So this brings us to packages. Now we can see packages is going to be containing multiple modules, and essentially what this is it is just a folder, and it can hold as many files as you want, although typically you don't want to have too many, as it can get a little complicated if you're a beginner programmer. And in each of these packages, you want to store your modules over here. And as you can see, we have two modules. So when you kind of create your package, this is what your package should look like. Alright, so say we have a package that we import, and we have the two different kind of modules inside that package. We have check prime module and we have hello module. And in order for us to use this, all we have to do is like the same thing that we did with the module, from package demo import check prime module, comma, hello module. And now all of the functions defined in those modules are now available in these programs. And we can see that when we want to call it, all we have to do is just the name of the module dot whatever function it is. So this is slightly different than what we saw in the singular module, as we do have to write, as we can see right here, we do have to write the check prime module in order for us to actually call the function in it. But other than that, there is no difference between calling each function, as all the functions in the two modules are available. So I'll let you guys look at this for a second. right? So Python packages allow programmers to do so much, and in there are over 130,000 Python packages available to us, ranging from everything containing like data analytics, games, natural language processing, computer vision, machine learning. And you may be wondering, well, all of this stuff is so complicated. All I want to do is say, um, write out a small program. But the thing is, with packages, it allows programmers to kind of connect, because a single programmer, as bright as they are, cannot outsmart, say, hundreds, even thousands of programmers. And the reason for why this is even possible is because, well, they can all import their packages and they can put on the web, and other programmers, it's not even say like a set group or anything, it can be any programmer that kind of that project catches their eye and they're like, oh, I think I can improve on this. And so this is kind of how programmers kind of build on each other's bases and make the other programs better. This is kind of like updating your packages almost. And so this kind of occurs in almost every single field of programming. In, say, games, the ways the updates roll out is you have to have different packages. And so when these packages are updated, then that means that the game files are updated. And when the game files are updated, that means that, well, everyone needs to switch to the new version in order for it to be kind of compatible, right? So in natural language processing, this is kind of like, say, improving the accuracy of the language processing. Computer vision, being able to track a certain object better, track a certain color better. And so we can see that packages allow us to easily work on any type of, say, programming out there. And so it can be literally any topic. And you will always be able to find someone who is willing to help you or willing to improve on your project, simply because of the vast number of people on these different kind of open source websites looking to help. Alright, so now that we've kind of gone over, well, how these Python packages work, there are many kind of common packages that beginner programmers will use, and these are Turtle, Tkinter, and Pygame. So, as you can probably guess, well, these are Python packages, so they're not necessarily automatically installed into your computer. So what you need to do is you're going to need to actually install them on your computer. So there's many different ways you can do this. You can go through command prompt. You can go to, say, websites to try and download them. But essentially, there's going to be many ways you can kind of install these Python packages on your computer. So I want you guys to kind of take a moment to kind of do a little research into any of these three packages, and over the next couple of days kind of play around with it. now that we've kind of gone over what modules and packages are, these can seem kind of confusing at first, but essentially what these are is these are just folders and files. So think of each module kind of like a file, say a picture file. And in order for you to say send this picture to your friends, you're going to need to like upload it or message them with it. And if you want to send multiple, say an album, then you would just store it in a folder and you would just send the entire folder to your friend, right? So that is kind of the basics of packages and modules. And now I'm going to kind of show you how you can install it. Alright, so this is Python Turtle. And Python Turtle is very useful if you're trying to just start learning graphics. And here's going to be their homepage. All it is pythonturtle.org. And so the reason why Python Turtle is so great for beginners is that since it involves graphics, it can be appealing at first, because it's always good to see kind of immediate results from your programming, as any programmer would like to see. And we can see this is kind of like a basic tutorial, I guess, on how to use Turtle. And so you can install it using any of these commands on these kind of oh my god, I don't have the word for it. Alright, I don't have the word for it, but essentially if processing something, I forget. But essentially, most of us will probably have either Windows or Mac, and you can install it at their website, which is going to be pythonturtle.org, and you just kind of click on whichever one that you want. Or you can go to GitHub. It is also on GitHub. Most likely you won't have these processing units, I guess. I don't know what to call it. But this is Linux. So Linux is actually a software based entirely on open source programming. So you can download Linux for free. There's no cost whatsoever, and typically this is on things like cheap computers, I guess. Ones that you wouldn't want to, say, buy Microsoft Windows for or something like that. But another use for Linux is, since it is an open source, that's what it is, operating system. Sorry, I blanked out for a second. So these operating systems, right? So Linux is a common one for programmers who are looking to kind of have more access to their computer, or be able to kind of directly control what's happening a little better. And we can see you can just kind of run the singular command in the command prompt, and you can kind of download it. And there's these other things like Fedora. There's also like GNU. Not entirely sure what those are, but Linux is very good if you're trying to get more, I guess, access to your computer, because with an operating system that you kind of have the code behind to it, then you can do much more because you know its capabilities, I guess. But that is only for the very daring programmers, because one wrong move and you could crash your computer forever and you could not get any of it back. Like your graphics card could fry, your operating system could fry, or not operating system, CPU could fry. So that's why typically people don't install Linux on, say, their work laptop. Alright, so that kind of wraps up our lesson on modules and packages. If anyone has any questions, then you can ask them right now. Alright, well it looks like nobody has any questions, so thank you everyone for watching, and we'll catch you on Friday.